We'll wait for 2 more minutes, then we can start the session. I will start the session by 6:02 or 6:03 something. I will wait for 2 more minutes. Okay, I will start the session. Meanwhile, students can join. I will share my screen. Can anyone acknowledge is my screen is visible and my audio is properly audible so that I can start the session? Someone has touched it. Okay, thank you. Okay, I will start. First of all, this is the second live session for the problem solving sessions for advances in welding and joining technologies course. The course instructor is Professor Sarupa, and I am the teaching assistant which will be handling the problem solving sessions for this course, and my name is Srihari. Uh, so in this session, I will be solving the assignment one questions of the last year's questions and this year's question. Since you guys already submitted the assignment question, we'll discuss today. So we'll get the brief idea how to approach those, how to solve those questions and all. So today I will be discussing the assignment one questions of this year and last year's assignment one questions. So basically involves the basically it is a discussion of fundamentals of welding and joining processes. Okay. So which of the following so first question here is like which of the following is not a permanent joining process? So A is welded joint, B is soldering, C is brazing, D is screw joint. So can anyone tell which of the following is a non-permanent joint? they can raise their hand or they can keep it in a chat box. Okay, fine. Soldering. Okay, someone has checked soldering. No, actually, strength in the soldering will be less compared to fusion welding or other welding process. But here they asked permanent joint. So here, if you see bolted joint or screw joints, there we can remove the joints, right? So not permanent joint. Here the third material is in soldering or brazing. The third material is melting and the help of wetting action, the joining is happening. So it's a permanent joint only. So to remove that material, we need to damage the joints. So here in soldering and brazing or in welding. But in screw joint, we can directly remove this nut, the bolts and the nut. So first option, the option is D. Okay. In the next question, consider the following statements regarding the fusion welding technique. So first of all, they are mentioned fusion welding technique. Okay. Then the cooling of the fusion zone is associated with the distortion, metallurgical changes, and residual stresses. This is the first statement, and the second statement is and the okay, one second. I think my now I think your entire screen is visible. Yeah. Now the second statement is like fusion welds are created by the coalescence of molten base metal mixed with or without molten filler metals. So first of all, anyone comment about this second statement whether it is correct or not? Means basically what they have mentioned. How, basically, it's the definition of fusion welding, right? Coalescence means joining of the molten base metal mixed with or without filler metals. So this is straightforward. Is basically the definition. So statement two is true. So next we'll discuss about so statement one. So due to the arc or due to the heat, the molten base metal is getting melted and joining. After joining, cooling happens due to the convection, and radiation losses. So first statement, what they have mentioned, the cooling of fusion zone is associated with the distortion, metallurgical changes, and residual stresses. So do you have the idea about residual stresses? I will wait for 2 seconds. If anyone comments, or else I will start. I will explain about the. So during welding, because of arc or any heat generation, the molten pool gets melted and joining happens. Yeah, fine. After joining, the cooling happens because of convection and radiation losses. During cooling, so what is the statement? The cooling of the fusion zone is associated with distortion, metallurgical changes, and residual stresses. Okay, first of all, we'll understand what is this residual stress first. Residual stresses are the locked-in stresses which are present in the component once external load is removed. Basically, these are locked-in stresses when there is no external load is present on the component. That is the definition of the residual stresses. So now we'll see how it is generated in a in a weld joint. How residual stresses are created. So basically residual stresses will be present in the component. So we'll see how residual stresses are originated in the welded component. So first of all, instead of explaining in the weld joint, I will start with a 3-bar arrangement. I will explain this how the residual stresses are generated. Then I will correlate this to the weld joint. So first of all, if I consider a 3-bar arrangement, uh, three similar bars which are joined with some rigid bar. So it will be a one single component. So now I will heat the middle bar. What happens if I heat the middle bar? Because of thermal expansion, this metal will tries to expand, right? Guys, if you have any doubt, you can put it in a chat box so that I can explain clearly. So there will be three similar bars which will be joined to rigid bar. So I'm heating only the middle bar. I mean side bar I am not heating. Initially these three bars will be in room temperature. So now I'll start heating the middle bar. Once I start heating the middle bar, due to the thermal expansion of the material, uh, it tries to extend. Obvious, right? The middle bar tries to expand. However, the sideboards restrict the expansion of the middle bar because it is attached through a rigid bar. So because of that, there will be compressive stresses generated in the middle bar and tensile stresses generated in the side bars. So this is fine. So this is during heating. So once heating is as the heating as the temperature increases, the compressive stresses are increasing because the expansion of this middle bar is restricted by the side bars since they are joined through rigid bar. So compressive stresses will be generated. Once the temperature increases, the compressive stress will be increasing till yield. So after once the heating is done, so because of conduction, convection, and radiation, the cooling happens. So during cooling, because of the thermal expansion, during cooling, thermal contraction happens, right? So this middle bar, since I am only heating this bar and cooling this bar, middle bar, because of the cooling, it tries to contract, but the sidebars won't allow because of this arrangement. So because of that, tensile stresses will be generated. Means contraction, it tries to contract in the sense this metal try to contract because of the temperature is reducing means during the cooling but this because of this bar it doesn't allow it to contract. So what happens, there will be reverse forces will be there, opposite forces, because of the tensile stresses will be generated in this component, and reciprocal to that there will be a compressive stresses generated in this. So during cooling what happens, there will be in the middle bar there will be a tensile stresses and tensile residual stresses, and in the sidebar there will be a residual compressive stresses are generated. So this is fine with the 3 bar alignment. Guys, do you have any doubt in this figure? If you have any doubt, please put it in the chat box so that I can make it clear. Not cooled below means someone has cooled below ambient. No, not cooled below ambient. It is here. This middle bar initially these three will be at room temperature. I will be heating this, so temperature will be increasing. Once after certain point of heating, I will allow it to cool to ambient temperature. I will allow it to cool to ambient temperature. During cooling, tensile stresses will be generated because the sidebar won't allow to contract because of temperature, thermal expansion and contraction. It tries to contract because its temperature is decreasing, but the sidebars won't allow to contract. So opposite forces will be generated. That's why tensile stresses will be generated in the middle component, and in the side components there will be a compressive stresses. So this in the I think I hope I made it clear. So tensile stresses will be generated. So if we want to correlate this 3 bar arrangement to the welding joint, so the weld metal and adjacent to the base of the adjacent base metal, it is can be correlated to the middle point. Means basically the temperature is increasing due to the arc heat generation and joining. Heat will be generated and temperature will be cooling. So it's like correlated to middle bar, and the side bars will be the areas further away from this zone is can be correlated to the side bars. So due to this correlation, we can directly say that there will be tensile residual stresses in the component, and as on the areas further away from the weld metal, there will be residual compressive stresses. So once the welding is done and clamps are removed due to the redistribution of thermal stresses and all, uh, there will be a tensile stresses in the weld joint, and the areas further away from the weld metal, there will be compressive stresses will be present. So these needs to be avoided in order to improve the better performance of the weld joint. So so we'll go to the again first statement. The cooling of the fusion zone is associated with the uh, distortion, metallurgical charges, and residual stresses. Oh, so as the cooling happens, residual stresses will be present. Okay, fine. So this statement is true. Now, because of the cooling, they have also mentioned distortion. Distortion in the sense, if you see in this, because of solidification, shrinkage, and thermal contraction, the weld metal and the base metal sometimes a tendency to distort, like out of plane distortion will be happening. Because once the stresses generated is more than the yield stress, then there will be a distortion. So distortion also will be there, which needs to be avoided. So proper clamping and also less heat input is required to reduce this residual stress and distortion. So distortion also will be present, and also microstructure changes will be happening because uh, in heat affected zone and fusion zone there will be microstructural change will be happening because the temperature will be more than, suppose if I consider a steel, the temperature reached will be more than the 800 degrees Celsius. So generally microstructure changes microstructure phase change which happens when the metal is cooling from the T85 zone, means when the metal is cooling from 800 degrees Celsius to 500 degrees Celsius, there will be a change in the temperature microstructure. So because of that, metallurgical changes also will be there. So again, metallurgical changes will be there, and also residual stresses, as I explained, will be there, and also destruction will be there. So these are not avoidable, but we need to reduce based on our strategy so that we can improve the weld time. So we understood that residual stresses, metallurgical changes, and distortion will be there. And as this second statement is directly a definition, so this is also true. So what the question is like. Consider the following. So statement. So in the second question, statement 2 is correct, and also statement 1 is also sorry. Both statements 1 and 2 are correct, right? Because this is definition, and as I explained, residual stresses, distortion, and metallurgical changes will be there. So this is how we need to understand residual stresses, distortion, material, and this question. So 2C, C is the correct answer. I hope I made it clear in this question. So I'll go to next question. Uh, so this question is like which of the as I said earlier, since some of the students have joined now, I am telling again. Today I am discussing the week one assignments of last year and this year's. I will be discussing the week two assignment in the next live session because the deadline is not completed, right? That's why I will be discussing the week two assignment next session. So I will be discussing the week one assignment and week one assignment of this year and last year's this course. So it will be useful for your understanding and also for your better understanding of this course, and also concept. I will get clear about the concepts and how to solve the questions. Also, you will get better idea. So, which of the following process use non-consumable electron? So the question is non-consumable electron. So what are the options are there? Shielded metal arc welding, plasma arc welding, gas metal arc welding, submerged arc welding. I think this question is very straightforward. Like, can anyone guess the answer in the chat box? I'll wait for 1 minute. If I don't get any response, then I'll explain the answer. Vivek has mentioned as B. Okay. Yeah. Yeah, Vivek, it's correct only. Means like shielded metal arc welding, as you can see here, the arc is stuck between the consumable electrode and the workpiece. And also we know that there won't be any shielding gases, and the electrode will be coated with the some flux which will get melt and creates the solidified slag and also shielding gases, and which protects the environment, which protects the molten pool from the environment. This is shielding gas, shielded metal arc welding or stick welding. Generally we will observe it in roadside welding, right? So there will be a consumable electrode in the shielded metal arc welding. Uh, and in gas metal arc welding means this is like GMAW or metal inert gas welding. There will be a metal which will get there will be a electrode which will be some kind of metal and the arc will be established from the base metal and this electrode, and this is a consumable electrode, and the arc melts due to the arc on the heat generation. The consumable electrode melts and deposits on the base plate. So obviously gas metal arc welding also, and shielding gases are provided externally to prevent the molten pool to prevent the molten from the environment to prevent the oxidation and all. So uh, so gas metal arc welding also have consumable electrode, right? Okay. And one more option they have given is submerged arc welding. As we know, it's also consumable welding process. Means consumable electrode only. Here there won't be any shielding gases. For the sake of clarity, I am explaining one more time. Here there won't be any shielding gases, and the arc is submerged under the granular flux. and the arc will be melting. Arc will be melting the consumable electrode and depositing, and welding happens and joining happens. This is generally used for thicker metals compared to GMAW or other metals. So, in plasma arc welding, we are using tungsten electrode welding. Here, as you can see in the figure 2, there is a non-consumable tungsten electrode, and because of the plasma and potential difference, there will be a generation of arc and welding happens. So, plasma arc welding is an so option for question for 3. The option will be 3B. 3B plasma arc welding is a non-consumable electrode where we use non-consumable. Can anyone guess which other welding process we use non-consumable electrode process? Last class also explained, even sir also explained. I will repeat my question. Which of the following processes uses non-consumable electrode? So, as we discussed, plasma arc welding is a non-consumable electrode because we are using tungsten electrode. Can anyone mention one or the other welding process where we use non-consumable electrode process? Someone can chat it, write it in the chat box. The question is straightforward, non-consumable electrode. So if we go to the classification of arc welding process, we'll have, I think no one has replied. Okay, fine. Uh, so what are the other process, other uh, rest, like what are the other process, other arc welding processes? Gas metal arc welding is there. So gas tungsten arc welding, GTAW or TIG welding, tungsten head gas welding, and also carbon arc welding is there. There also we use tungsten. So these are the so apart from plasma arc welding, gas tungsten arc welding, and also carbon arc welding where we use tungsten electrode, which is a non-consumable. So this also comes under that category only. And electron slag welding, there also melting will happen, thermit also melting will happen because mixture will melt. I hope this option is also clear. Guys, this fourth question is very straightforward. I think that someone will in the chat box. So which of the following statements which of the following statements are incorrect regarding the brazing technique? If you know the definition of the brazing technique, this is straightforward. Like they have here in this the options. If you know the brazing definition, you can directly answer. So first, which is the incorrect? So dissimilar can be joined. Small and wide gap joints can be joined. The filler metal melting up is less than 450 degrees Celsius. Different geometries can be joined. Can anyone tell which is incorrect? Uh, Someone has stated B. Okay. Only one or two ways are active, and rest of the things. See, this should be interactive session so that you guys also will understand better. Someone has said like B, small and wide gap. Okay, someone has stated can be filled. No, this the question is like incorrect, not correct. See, brazing and salting, what is the main difference? In brazing, the temperature will be greater than 450 degrees Celsius, and in salting, the temperature will be less than, yeah, someone has stated C, yeah. In salting, the temperature is less than 450, but this option is related to salting, so it is incorrect with respect to brazing. So 4C is the correct answer. I hope I made it clear. So we'll see the next question. Consider the following statement regarding the thermit welding. No, in general, we'll consider it as more than 450. Yeah, sometimes the temperature will be 600 also. Okay. Consider the following. I see. Basically, if you guys know the definition of each welding process, most of the solutions will be solved. In some other questions, you know in bit detail. So in this also, consider the following statements. And also, main thing is like you need to know arc welding and laser beam, electron beam in detail. And rest of the things, by definition, we will get the most. We can solve most of the solution, most of the questions. So next question is consider the following statements regarding the thermit welding. Okay, so first statement. A separate heat source is utilized to perform the welding. And next statement, the molten metal produced by chemical reactions of the component of the thermite acts as a filler metal for joining the workpieces. Okay, someone has chatted like C is the answer. Okay, okay. Both statements 1 and 2 are correct. Okay, here, see, this is thermite welding, right? Due to the chemical reaction, exothermic chemical reaction, heat will be generated, which will be used to weld this. Due to the exothermic reaction between the metal and the metal oxide, there will be a heat will be generated. That heat generated will melt the metal, and this melted metal will be used as a filler metal for joining the workpieces. So, from that, statement 2 is correct. And here we are not using any separate power source, right? This exothermic reaction is used for generation of heat. So, statement 1 is false. So, in fifth, B statement 2 is correct and statement 1 is incorrect. I hope I made it clear. So I'll explain. I'll go for next question. Let me see in chat box. Okay. First of all, droplet continues to grow until gravitational force exceeds the. Okay, someone has chatted like some heat is required to generate the. Okay. Uh, okay. Yeah, but it is not separate at the initial stage only it's required. Once it started, that is not required, right? Someone has started like initially to generate the to start the chemical reaction, some heat is required or some initiation is required. That is only at the initial stage. Once it starts, the chemical reaction proceeds and welding will happen. So at the initial only it's required, but till complete the completion of the welding process, it's not required. During welding, it's not required. So that's why 5B is the appropriate one. So, and guys, last time you guys said that these fonts are not clear. I think this time the fonts will be are clear. If you guys have any problem, let me know. So I'll further make the fonts higher, larger, so that it will be visible. I think this time it's better. Okay. Okay. Next question. Droplet continues to grow until gravitational force exceeds the surface tension for dash mode of metal transfer. Okay. First of all, spray transfer. Yeah. More, few of them are charted as C. Yeah, globular transfer. Yeah, answer is correct. So first of all, the question spray. Yeah, C is correct answer. First of all, spray transfer, short circuiting transfer, globular transfer, dip transfer. So the main metal mode transfer are these three: spray transfer, short circuiting transfer, globular transfer. In spray transfer, because of high current, the metal gets melted in the form of droplets, and the droplets size diameter is less than the electrode diameter, and it will be transferred. This is a spray transfer. In short circuiting, so this figure explains about the spray transfer. And in short circuiting transfer, what happens? There, the gap between the electrode and the base plate will be less. Okay, first that is the one point. Then once the arc is generated, and also current is also less compared to all these process. Short circuiting current is less. So once the arc is generated, because of that heat will generate and motor will droplet forms. But since current is less, the detaching force is less. Means that electromagnetic force and other forces are less. So detaching force is less. So and also electron gap is less. So as the process proceeds, the molten droplet, since there is no more detaching force in the sense the force required to detach the droplet from the electrode and to deposit the droplet on the molten core. So here current is less, so so detaching force is less. So this droplet won't detach. So since the gap is less, it will touch the it will directly touch the base plate. So short circuiting happens. So due to short circuiting, at the short circuiting, again the current is less than compared to globular or spray. So here we intentionally increase the current, little increase the current, and since it short circuiting happens, voltage will be zero. So because of this increase in current, the detaching forces increases and droplet transfer takes place. So this is there is no much of gravitational force in this also, right? We are increasing the temperature little bit, as we can see in this figure. We increase the current little bit so that droplet so that deposition happens. So this is short circuiting. In globular transfer, as you guys said, answer is C. Means here current will be between the short circuiting and spray transfer. So and also gap is more. Gap is more. So because of high current, the droplet formed is the droplet formed the diameter of the droplet formed is more than the electrode. So so the electrode droplet is increasing. So obviously the weight is increasing. So because of the gravitational force, the droplet gets detached and deposition happens. So in 6C is the suitable answer. And also this 7 questions are directly discussed in the first week module. If you guys have followed this, you would have directly known this, and by intuition also you can tell directly. Can anyone tell the answer? Which of the following welding techniques can be performed by modifying the scanning electron beam microwelding? Yeah. This is straightforward only. So directly electron beam microwelding is the correct answer. Okay. Seebeck effect is observed in dash technique. Okay, first of all, Seebeck phenomenon is in this when there is a temperature differences between two similar electrical conductors, because of the temperature difference, potential difference creates. That is the Seebeck effect. So, uh, 8D is the answer. This is directly from the basics of electronics. We will get these things. Okay, please explain. Okay. Uh, so, uh, because due to thermodynamic emission, the electrons will be generated and it will be traveling towards the base plate, right? Uh, so the electrode will be different material, and I will in a crude sense I will explain. Electrode will be different material, and this will be different material, and the temperatures also different. And the Seebeck effect, what is the Seebeck effect? This is a phenomena in which, due to the temperature differences between two dissimilar metals between the electrode, and we can correlate to the electrode and the base metal, there will be a temperature difference. Due to this, potential difference creates and thermodynamic emission happens, and welding happens. So 8D is the option answer. I hope I have made it clear. If you want further explanation, I can, with the proper figure, I can explain the next session. I thought like this will be, I think even in next session of electron beam welding will be there. In the next session, I can explain this with the help of figure also. Yeah, this arc initiation, arc stabilization, arc rotation, and upsetting are the 4 stages of dash. I think this is also straightforward. As I said earlier, uh, if you know the definition of the what is the meaning of the process, you can directly attempt the question. So I hope that someone will put it in a chat box for the 9th question. Yeah, only few guys are only active, and others are just listening. If you guys are active, then you understand better, which will be it is useful for you to understand. Okay, fine. Arc initiation, arc stabilization, arc rotation, and upsetting are the 4 stages of magnetic impelled arc welding. This explained better in the first model itself in the first week. There will be two pipes. Generally, it's used for pipe welding or something like that. And when there is a potential difference, the arc will be generated, and this arc, due to the help of magnetic system, it will be rotating, and it will get stabilized. So first arc initiation happens, then arc stabilizes, and with the help of magnetic thing, it will be rotated, and finally pressure will be applied. That upsetting will be done to join the metal. And due during this, when the arc is generated, this gets heated, and not up to the melting point, but this gets heated. Once the pressure is applied, because of the frictional heat also, the joint happens. So magnetic impelled arc butt welding is the answer. So what about the other things? Thermal welding, as we explained, because of the exothermic reaction, this happens. Electron beam welding also. This is the thermionic emission of electrons from the electron to the base plate. The welding happens. And activated TIG welding is basically TIG tungsten inert gas welding. We'll have applying some kind of active elements like some kind of sulfur or oxygen flux will be applied on the base plate, so that we can apply decompensation. So option 9 is the answer. I hope you guys are clear with this. So next question: process by which physical properties of the adhesive are joined from liquid to solid. This is also straightforward. Means liquid to in the adhesive bonding, generally the adhesive is used to join the two materials or two structures or anything. Initially, it will be in the liquid form. Once once the two structures are once the adhesive is applied to the metal and the two structures are joined, and the liquid to solid process is called curing. Then this is straightforward, right? Yeah, B is the answer. Yeah. Okay. Till 10 the 10 questions. These are the last year assignment 1 questions. So now I will be discussing this year's assignment question. So the question is, identify the correct and incorrect with respect to oxyacetylene gas welding. So oxyacetylene gas welding. So first of all, before looking into the question, we'll understand in oxyacetylene filling there will be neutral flame, carburizing flame, oxidizing flame. In neutral flame, the ratio of the oxygen to acetylene is 1:1. So it's called neutral flame. However, in carburizing flame, proportion of acetylene is more. So there will be excess carbon also. So it's called as carburizing flame. And next, in oxidizing flame, as the name suggests, the ratio of the oxygen will be more, right? And also in carburizing flame, since oxygen supply is less compared to neutral flame, obviously temperature will be less here, and also sir explained in the class, and also temperature will be more here since more oxygen is supplied. So for 11th, the temperature of the carburizing is higher than no. This is false, right? Okay. Then welding of iron and steel using carburizing flame in the oxidizing flame produces very hard. Yeah, because of excess carbon, during welding of steel or iron, there may be chances of formation of iron carbide, which is bitter. So second one is correct only. Next, in case of neutral flame, the mixture is the definition itself. It's 1:1. So this is also true. In oxidizing flame, less oxygen than compared to the neutral flame. No. Here the oxygen will be supplied will be more compared to the neutral flame. So 1 and 4 are false. So what they have asked, correct and incorrect statements. So in this C option, if you can see, 2 and 3 are correct, yeah, and 1 and 4 are incorrect. So 1C is the answer. 11 for 11th question, C is the answer. Okay, next question. I hope I made it clear. You guys have any doubt, you can put it in the chat box. Okay, no one has put it in. Okay, I'll continue. Identify the correct pair welding process and the corresponding protecting medium in the following fusion welding process. So first of all, for this you guys need to know the basically the name itself suggests what we are using and all. Shielded metal arc welding, gas metal arc welding, submerged arc welding, gas tension arc welding, and plasma arc welding. In plasma arc welding, whether we are using shielding gas, yes, we are using shielding gas. And so this is correct. Yeah, someone has said, yeah, A is correct. I think you guys have solved this. I think at least you guys should be active at least when solving these questions. Yeah, A is correct. What about shielded metal arc welding? Yeah, flux produces protecting gas from the weld pool. Yeah, it's also true. I'll show the diagram also once. Gas metal arc welding. Yeah, I'm using shielding gas. But submerged arc welding, the answer should be like shielded, provided shielding provided by flux granules, right? Submerged arc welding. The arc is submerged under the granular flux. So this was the answer, but there is a wrong match. So this is wrong. And gas tungsten arc welding shielded provided by, no, it's provided by gas tungsten. Name suggests gas. Shielding gas is used. So shielding gas. So these two are incorrect. So option is for 12. I think these two are wrong. So 1, 2, and 4. So 12A is the correct answer. Even in the figure 1 also explains gas tungsten arc welding. The shielding gas will be supplied, and because and the potential difference between the gas tungsten electrode and the base plate, arc is generated, and joining happens. This is the gas metal tungsten arc welding. And similarly, as I explained in the other question, shielded metal arc also, there will be a flux coated on the flux coating, which will get melted and forms the shielding gas in solidified form to prevent the molten cool from the environment. So gas metal arc welding, I'm just giving the definition. Gas metal arc welding, same thing. Shielding gas will be provided, but here instead of tungsten, here we use metal electrode, which will get melted and deposited. So in that option, they have mentioned in submerged we are using shielding gas, but that is not the case, right? We'll be using granular flux, which will be submerged under the arc. So since the granular flux will be there, you are not able to see the arc because there will be flux. This is the in this process we are compared to in other arc welding process, we can see the arc creating tungsten, GTAW, GMAW, plasma, GSMAW. We can see the arc here in submerged arc welding. We are not able to see the arc. And this is the plasma where we have used shielding gas to protect the environment. So I think this question is also clear. Yeah. So 12 answer is here. These three statements are correct. Identify the incorrect statement with respect to the mode of metal transfer. Right? In the metal transfer, Lorentz force is type of retard force. No. Lorentz force in the sense electromagnetic force. Lorentz force is the force which is generated due to the electromagnetic field present in the welding process. So it is a detaching force, not retarding force. Welding surface tension is the retarded force. That is the attaching force. That's why it is the surface tension force is the uh, attaching force. Means it won't allow to detach the droplet from the metal. But Lorentz force, electromagnetic force is the retarding force. And welding, so this option is wrong. Someone has told B. Okay, let me. Yeah, I think that correct only. Welding current density is higher in case of as no, because in spray transfer, because obviously we know that compared to globular or circuiting, as I explained earlier, the current is more in spray transfer. So obviously current density will be higher. So this is also wrong. These two are incorrect. So in the case of globular mode, this is straightforward. So this 3 is correct. And in case of globular mode of metal transfer, welding current is more than short circuiting current. Yeah, this is also correct. So 13B is the answer. I hope you guys are clear for this question. Have clarity in this question. Again, this MIAB. Again, magnetic impelled arc, but I just now explain. Can anyone tell the answer? 14th question. C. Can anyone tell the answer for this 14th question? Only, okay, yeah, C is the correct answer. Because initially arc initiates due to the potential difference and this arc stabilizes, and as the arc stabilizes because of the magnetic system, we locate the arc and the surface of the pipe or metal getting heated. Once it is upset, it means we are applying the pressure to create the frictional heat. Because of that, joining happens. So 14C is the answer. This also sir has also explained, and also in last class I have discussed about this question. C, 15C. Yeah, C. I don't know whether you said the answer for 14th or 15th, because both option, for both questions the solution is C only. Okay, anyway, first of all, direct current straight polarity. Direct current straight polarity are direct current electronegativity are one and the same. So first of all, we understand the direct electronegativity. Means electrons will be traveling from here to here. Once the electron is traveling from here to here, yeah, C is the correct answer. Once the electron is traveling from here to here, what happens? Because of this kinetic energy, heat generated will be more because electrons have more velocity compared to the positive ions. So there will be higher penetration. Today this session I want to explain about surface cleaning and all. Just I'll explain about this with respect to this question itself. And if you guys like want to understand, it will be uploaded in the YouTube. You can watch the last sessions video will be uploaded. Every sessions will be uploaded on the YouTube. If you guys have any doubt, you can type the course name and you get the in my name you will get those videos. If you want, you can watch those. Okay. So direct current. So it's deeper penetration, right? So deeper penetration means so used to join thick sheets. Yeah, obviously because deeper penetration will be there, so you can directly use for thick sheets. And use it for non-consumable. Obviously, the since non-consumable electrode, it won't take part in the. If it is consumable, the molten metal will the metal will melt and forms a droplet, and and the detachment of droplet takes place in the molten fuel, and deposition takes place. But in case of non-consumable, there is no such thing. Then there is no requirement of more heat in the electrode side, right? So, so DC direct current straight polarity DCEN is used for non-consumable electrode. So A1 stands for B3B4. A1 B3 A1 B4. Yeah. C. So so C is the correct answer. So anyway, we'll see for reverse polarity also. Reverse polarity also. DC direct current reverse polarity means electron positive. Due to electron, electrons will be traveling from here to there. So heat generated will be more here. So obviously melting of the electrode takes place and deposition takes place, right? So we can use it for consumable electrode. And since we get the shallow weld, we can use it for thin sheets. So A2 is like B1 B2. A2 B1 B2. So 15C is the answer. See, by the name and the concept, most of the times, if you know the definition or the basic of the process, you can solve most of the questions, at least in this course, for assignments. Okay, again, we have discussed initially about this question. Identify the incorrectly matched pairs. Can anyone tell a bracing? And as we discussed, the fundamental joint is greater than 450 degrees Celsius, right? Yeah, obviously more than 450 degrees Celsius. I'm waiting for your answer. Okay, let me discuss. Let me see some chance. We'll see. A 16 year, right? Yeah, this one is correct. Incorrectly matched pair, right? Ultrasonic welding involves melting of parent metal. Is that so? No, right? Because it comes under solid state joining, means there won't be any melting. If only in fusion welding and all, parent metal will be melted. So this is incorrectly matched. So 2 is incorrectly matched. And gas metal arc welding falls under solid state. No. Actually, this portion should be interchanged, so then it would have been correct. So 2 and 3 are wrong, and thermal welding involves chemical reaction. Obviously, it's correct. So 2 and 3 are wrong, incorrectly matched. So 2 and 3. So 16A is the solution. Only last 2 to 3 questions are there. We'll discuss this and we'll end up anyway. We have session till 7, right? This question is directly like discussed itself in the class itself. Which of the following statements are true or false with respect to arc efficiency? if A represents the heat generated at the anode and B represents the total heat generated in the arc efficiency is identified by P by E. This is wrong, right? Because they have just mentioned anode and okay, we'll see next question. In consumable arc welding process, heat is generated only at the cathode for melting of heat is generated only at the cathode for melting of filler and base metal. This is also wrong. Consumable because they haven't mentioned whether it is DC, PDC, and if this is positive or negative, something like that. However, in the consumable arc welding process offers higher arc efficiency than non-consumable arc welding process. This is discussed in the class. Means consumable arc welding process means because the heat generated at the electrode also will be utilized in the molten pool, right? Because electrode melts in the electrode because of metal at the electrode melts and it deposits again in the molten pool. Because of that, heat input like arc efficiency will be more, right? Because heat utilized is more. So this third one is correct. And the next question, the heat from the welding arc is lost by conduction to base plate and convection to the surrounding. Conduction and radiation. Yeah, this is during once the arc is generated, the welding arc once the welding is done because of the welding arc, base metal and if it is consumable electrode melts and deposition happens. Welding once the welding is done, cooling takes place. During cooling, basically this is basically straight engineering, straightforward heat transfer, heat and mass transfer of thermodynamics question only. It's once the any material gets heated, it used to be cooled if it is in normal ambient temperature, right? Generally, most of the applications will be at the ambient temperature. And also after welding, it gets cooled because of the conduction to the base plate and by convection and radiation to the arc plate. So these 3 and 4 are correct. So 3 and 4 are correct, and first and 2 are false. So option is 17C. I hope I made it clear. Next question. Select the appropriate option to fill the gaps generated related to thermal welding involves exothermic or endothermic. I think you guys should tell no only. It involves exothermic or endothermic. And, yeah, D. Yeah, D correct. Why? Because exothermic means heat generation will be happening. So obviously because of that only welding is happening. Exothermic, so thermic welding involves exothermic chemical reaction between a mixture of metal oxide and aluminum powder. Yeah, that is true. So exothermic. So C or D will be the answer. And the chemical reaction occurs via both oxidation and reduction takes place because one metal will gain oxide and other will be now losing the oxide. So reduction and oxidation takes place. So 18D is the answer. Okay, next question. Last 2 questions are there. Match tab adhesive bonding. As again sir discussed in the class, adhesive bonding. In adhesive bonding, we need to mode of failure. We need to match the mode of failure with the cause of failure. So first of all, adhesive and cohesive is there. Even in your casting and now you would have studied. Adhesive means joining of one material to the other material. That is adhesive property. Cohesive means in a given material itself how the bonds are joined. Means with respect to casting, in that sand will be there. No sand with the mold. If it is joining, then it is called adhesive property of the molding sand. But in the molding sand itself, there will be a joint, right? Because of the clay and all, there will be a joint. That is called cohesive property of the molding sand. Similarly, cohesive means in the material, adhesive is between 2 different materials. So with it, we will see the structural failure, adhesive failure. So someone has texted C, chatted in the C because first, basically because this definition itself you can directly answer, right? Adhesive means uh, interfacial failure means between the adhesive and the metal which is needs to be joined. So obviously adhesive property, right? Separation of one of the substrate is the adhesive layer. So A to B1 is correct. And cohesive failure means internal failure substitute in the region A3 and B3, right? Yeah, internal failure. Cohesive means within the material itself. Internal failure, the adhesive layer. So within the material itself. This adhesive means between the bond and the metal. So A2, B1 and A3, B3. And structural failure means so A1, B2. Internal failure in region close to the joint. So substrate material. So that is structural. So basically by name itself you can easily answer this question. So 19C. For that you need to know these definitions: adhesive, cohesive, and okay. Last question. This is also discussed in the first module or in the first week. Yes, uh, basically, first of all, you know about the gas tension of welding, right? Uh, someone has raised and you can write it in the chat box, right? So that I can. Okay, I didn't get any response. Okay, fine. I will explain the GTW process first and then activated GTW. As the name suggests, if you see in this figure, uh, as the name suggests, this is it gas tension of welding. Tension electrode. Obviously, it's non-consuming electrode. So, arc is stuck between the non-consuming electrode and the workpiece, and it is used for thin sheets generally. Due to the arc generated, that heat, because of that heat is used to join the metal pieces. And suppose if you want to join thick plates, I will be using filler metal externally. And to protect the molten pool from the environment, we are applying shielding. This is the basic definition of this gas tension of welding, right? So what is this? Now what is the activated gas tension of welding? Means to achieve higher penetration, we will be using some kind of activating agents. Means we'll apply some kind of flux over the basement before welding, and then suppose this is a basement, and this needs to be, I think it is visible, right? Suppose this is a basement, if you consider bed joint, I need to join this, or lap joint, I need to join this. So I will apply suppose this is a basement, I will apply the flux, and because of the arc generation, the molten pool behavior of fluid flow will be changing. So because of that, higher penetration will be achieved. So basically, what's happening is like in general, this is the case for normal GTW without using surface active elements. Surface active elements in the sense like we use oxygen or sulfur something which will be applied over the uh, workpiece and welding will be happening. So without using active elements, what happens is like as the temperature increases, surface tension decreases. So at the center, surface tension will be less. As we go away, temperature is reducing. You can see in this figure, right? Negative slope. This is the negative slope. As we go away from the center of the arc, obviously temperature will be reducing, so surface tension will be increasing. So, uh, so the force will be like this. The forces will be like this towards away from outside, like this. The mirroring convection will be more fluid flow will be like this. So it will be shallow. But if you apply surface active elements, the trend will change. Means the instead of negative slope, we get the positive slope. Means as the temperature increases, surface tension increases because of the surface applying the surface active elements. So because of that, surface tension will be more here, and surface tension will be less here. So there will be a this kind of behavior. I think you are able to see my cursor. So there will be deep, the fluid flow will be changed and it will be towards the center because surface tension is more and less here. So there will be a dragging from here to here. So there will be a okay. I will use pen. Then there will be this kind of fluid flow. Here there will be this kind of fluid flow. So something like this. So here we will get shallow well. Here we will get deeper penetration because uh, you will get like this kind of fluid flow. So because of that, there will be a deeper penetration. So now, since we understood this, we'll see the options now. So compared to the GTW, in the activated gas junction of welding, deeper penetration, depth of penetration decreases. No, actually it's reverse. So statement 1 is incorrect. Application of the results in reduced residual compared to GTW. Yeah, one perspective we can see is like reduced residual means because of this the current required is less. Since the current required is less, obviously heat input will be less. As I said earlier, heat input is the culprit to generate the residual stresses as discussed earlier also. So there will be a reduced residual compared to GTW. So 2 is correct. And the active enhances the because of this you can use higher welding speed, so enhances the productivity and reduces the cost of fabrication. So this is also correct. So 20C is the option. I hope you guys are clear. So these questions are done in last class. Someone have asked about the keyword mode. Anyhow, in this I think second week, sir has explained about the keyword mode in friction welding and also in electron beam welding. Basically, what happens is that there will be two modes. If we consider laser, conduction mode and keyhole mode. In conduction mode, the temperature generated is not more than the vaporizing temperature of the molten pool, so there won't be any vapors. But here, the melting the temperature generated is more than the vaporization temperature more. So the here molten pool gets vaporized at this zone, and this because of that there will be arc pressure. So because of this arc pressure, there will be a kind of hole form. Hole will be formed. It's called keyhole. And due to this arc pressure, this will be maintained. And adjacent to that, there will be a pool which has a temperature more than melting point temperature, and this will be maintained. Once the arc laser moves, this keyhole will be filled by this molten point deposition. Because of this, the electron beam will go penetrate deeper, and because of that, deeper penetration will be achieved with keyhole. This is the brief discussion. I am giving it brief because sir already discussed about the conduction mode and keyhole mode in laser. I think that's it, guys. This is all about today's session. If you guys have any doubt, you can chat it